Hello everyone, good morning. It's another lovely Thursday and today we're having mathematics. But before that, I want us to look at one of the errors that are common, some errors that are common in mathematics. We'll just look at one for today. Okay, so subtracting A from B, for example, you have a number that is to be subtracted from another number. Let's look at the mistake that some people actually make, and let's see what the correct thing is. So for example, you're asked to subtract 50 from 24. Subtract 50 from 24. Now some people do this. Some say 50 minus 24, right? This is wrong. This is not correct. This is not correct. When you're asked to subtract 50 from 24, it's in English language, if you're taking something from something else, you know, the number at the end of that statement is your starting point. So when you say subtract 50 from 24, meaning out of 24, you're to remove 50. So instead, you should say 24 minus 50. Now, the number that you're subtracting from might not always be the bigger number. Okay, but just note that when you're asked to subtract a number from a certain number, the reference point is the number at the end of that statement. Okay, some of us might be mixing this up. It's a simple one, but some of us might be mixing it up. So subtract 50 from 24 does not mean 50 minus 24. It means 24 minus 50. And that applies to every other thing you might be dealing with, especially with word problems. In algebra, when you're asked to subtract x from y, and some people would say x minus y, okay, it should be y minus x. Okay, so that's just something you should note. Okay, you should note that. Okay, so let's move on to our topic for today. Yes, okay, but let's talk about what we should know. What we should know. Now, in our last class, we were talking about logarithms. I don't know if you still remember that, but we're talking about logarithms. So we're still going to do that today, and we're going to finish up the topic today. So today you should be able to find the logarithms of numbers less than 1, and you should be able to, you know, do some calculations involving logarithms. We did some the other time, but we're just going to move a step further today and look at logarithms of numbers less than 1. Okay, so logarithms, yeah, we're still on that. So let's review our laws. Remember these laws? I hope you remember them. Let's just bring them all out. Okay, so these are the laws that we have been using, the principles that we've been using. When you have a number, two numbers multiplied together and you find the logarithms, then you would do the addition of those logarithms. So multiplication in logarithm is changed to addition, division is changed to subtraction, and then when you have a number raised to a certain power, if you find the logarithm of that number, you need to multiply by the power. So when you raise to an exponent, then that changes to multiplication by that exponent. So the same thing applies to finding the root of a number. You would divide by that root when you find the logarithm of the number. So it's very important. I always start with this because you need to know what you're doing before you embark on that journey. You have to understand, okay, what are the principles that actually guide this journey I'm about to embark on. So you have to understand the principles of logarithms before you can take on any calculations. So it's important that you remember these laws. Okay, all right, so after all the calculations have been made, remember we did that after you've done all the calculations in the logarithm column and probably the third column, you would then have to change your final answer using the Antilog tables. You have to now, you know, use the Antilog table to get your final answer. You cannot leave the answer in terms of logarithm. Since you're just trying to use logarithm to carry out the calculation, you should still change back to the, you know, normal number. Okay, so let's go on. Now, how do we find the logarithms of numbers less than 1? Now, we've seen this in the previous class. I said we should try to, I think you should have a hard copy of your four-figure table. You know, it should contain logarithms, squares and square roots, sine, cosine, and tan, and all those, you know, important concepts. So for this, I just snipped a part of the logarithm table. So, but you know how this looks like. You have the numbers on the left, you have the zeros to 9, then you have the differences from 1 to 9. So I think we looked at also how to check, you know, the logarithm table. We'll still do that again today. So let's take an example. Find the logarithm of the following numbers. We have 0.125 and 0.035. Now let's start with number 1. Remember that we have said previously that you need to change whatever you're finding to standard form. If you're finding a log of any number, you need to change it to standard form first of all, because that will determine the characteristic. Let me show you what I mean in case you've forgotten, but you could also go back and really revise the previous video if you are having difficulties remembering this. So 0.125 now is 1.25 times 10 raised to the power minus 1. Now the logarithm of a number consists of two parts, the integer, which we refer to as the characteristic, and the mantissa, which is the decimal portion. So that raised to the power of minus 1 here is going to serve as our integer, our characteristic. But we would not write minus 1. We would not write minus 1. We would write bar 1. We call it bar 1 in logarithms. So a 1 with a bar on it. A 1 with a bar on it. Then we move on to check 12 under 5. Remember, we have 0.125 and it became 1.25 times 10 raised to the minus 1. So we would check 12 under 5. So let's go. 12 under 5. You can see this is 0.969. So our answer is bar 1.0969. So I want you to also get your table, a four-figure table, and check this. Be very sure that you're following. Let's take the second example. We have 0.035. Now we change that to standard form. That would give us 3.5 times 10 raised to the power minus 2. And as usual, this minus 2 would give us our integer. But remember that we do not write minus 2, we write bar 2. That bar there is what represents our negative. So bar 2, then we check 35. Since there's no other digit, we just check 35 on the 0. So 35 here on the 0 is 5441. 5441. So that's the answer. Bar 2.5441. So you can also check to be sure that you're following. Okay, so Antilog is the same concept we applied in the previous one. So you can see the Antilog table here. That's just a snippet. Let's take an example quickly. So for example, you have these two numbers now, bar 3.5710 and bar 1.6521, and you're to find the Antilog of these numbers. Okay, what do we do? This is our table. Now let's start with the first one, bar 3.5710. Now what you're going to do in this case is you're going to pick, okay, you're going to pick 5710, right? You're going to pick 5710. So 57, you check 0.57, okay, it looks like 0.5, but just say you check 57 on the 1, and then there's no difference, there's a 0 there, so you don't need to check the difference. So 57 on the 1, that gives us 3.724. So 3.724 now times 10 raised to the power of what? So to get the Antilog, you check the fractional part, that's the decimal part. Then to get the power of 10, just look at the integer part. The integer part there is bar 3. So our answer would be something like this. 3.724 times 10 raised to the power of minus 3 now, because our integer was bar 3. So if you simplify that and put it in ordinary form now, that would be 0.003724. So it's not difficult. It's not difficult, but it's very important that you can do this without any assistance. So it's important that you practice. Check as many as possible. Check as many as you can and get familiar with the usage of a four-figure table. Then let's take the second example before we move on. So by 1.6521, same thing happens here. You would check 65 on the 2, difference 1. So this is 0.65 here. On the 2 here, 4.487. Okay, I hope you can see that. I hope you're following. Difference 1 here is 1. So 4.487 plus 1 is 4.488. So 4.488 times 10 raised to the power of what? Times 10 raised to the power of what? Now, our integer part is bar 1. So automatically our answer becomes 4.488 times 10 raised to the power of minus 1 now. 10 raised to the power of minus 1, and if you put that in ordinary form, you would have 0.4488. Okay, so this is the basis for finding the log and anti-logarithms of numbers that are less, when you're dealing with smaller numbers, as numbers that are less than 1. So it's important that you understand this. Okay, now we can then say, let us analyze numbers with bars. When you say bar 1 point this, what does that mean? I want you to note that bar 1.6521 is not necessarily, in mathematics we know what minus 1.6521 means. It's not necessarily the same as bar 1.6521. There's a slight difference. Pay attention. So what's the slight difference? Now, bar 1.6521 is minus 1, okay, on its own, then plus 0.6521. Okay, so minus 1 on its own, then plus 0.6521. But minus 1.6521 is minus 1 minus 0.6521. So you can see the slight difference. It's a very slight difference, but it is important, especially for the fact that if you try to use a calculator to get logarithms of minus something, okay, it will give you some complications if you don't know how to separate these values, this bar and the likes. So you need to understand that bar 1 point anything is minus 1 plus the fractional part. Okay, not minus 1 minus the fractional part. So that's the slight difference. So that brings us to how do we add and subtract these bar numbers? How do we multiply? How do we divide and all of that? So let's look at addition and subtraction. Let's start with that. So for example, I have about 2.9159 plus 0.8136. Okay, how do I add this together? It's simple actually. It's not difficult, so I'll write this. Now we do a normal addition. 9 plus 6 will give me 15. So I write a 5 here and I carry a 1. So 5 plus 3, 8 plus that 1 becomes 9. Then 1 plus 1 gives me 2. And 9 plus 8 would give me 17. So I write a 7 underneath here and I carry a 1. Okay, now this is where at that bar position is where you need to be careful where the bar is. So 1 plus bar 2 now is 1 plus minus 2, which is actually 1 minus 2. Okay, we can neglect the 0 since that doesn't change anything. So 1 minus 2 now is minus 1, right? 1 minus 2 is minus 1, so that is bar 1. Okay, bar 1. It's important that you understand how to do these additions and subtractions, because some people find it difficult to do the bar addition. Okay, so when you're carrying anything to the bar, you just treat the bar with as the negative, but make sure you do the normal addition starting from behind. Let's look at another example. Look at this now. We have 0.8326 minus bar 2.9731. How do we subtract these two values? So look at this. Now 6 of course can subtract 1, that would give us 5, but 2 cannot, you cannot take 3 out of 2, so you borrow 1 from 3, that would give us 12 minus 3 now, and our answer would be 9. Now remember that what we have left here is 2. Okay, you can actually write it down and try to do it on your own. So what we have left here is 2. we take 1 from 8 and that becomes 12 here. So 12 minus 7 would give us 5. Then remember that we have 7 left here. We have 7 left here now. So 7 cannot subtract 9. So we're going to take 1 from 0. Now, it's unheard of. I know you've never heard of taking 1 from 0 before, but yeah, that's what we're going to do here. That's what we're going to do here. So you take 1 from 0 and it becomes bar 1 now. Becomes bar 1 now, because if you do 0 and you take 1 from 0, it becomes minus 1. So we're just going to call it bar 1. So this becomes bar 1, and then you put a 1. You know, this is 7 here now. It's 7 that's left here. So that will be 17 minus 9, and that would give us 8. Now, this is the crux of the matter. Bar 1 minus bar 2. Bar 1 minus bar 2. Okay, remember now that the bar here can translate to minus. So bar 1, that's minus 1 minus minus 2. Minus 1 minus minus 2. Now that gives us minus 1 plus 2 now. Minus 1 plus 2 now. So that would give us 1 here. Okay, so it's important that you're very careful, especially when you're dealing with numbers that are less than 1 and you're doing logarithms. It's very important, very important that you're careful when you're carrying out either addition, subtraction, any arithmetic operation. You need to be very careful with the bars. Okay, so let's take multiplication and division now. Now, you don't just multiply the numbers directly. You have to work some kind of, well, I say, okay, it's not magic anyway, but you have to do some manipulations before you can carry out these operations. So, for example, I have about 2.9294 times 3. Okay, so I could separate this. Remember that we've said about 2.9294 is not the same as minus 2 minus 0.924. It's bar 2 plus 0.924. So after separating this, I can then multiply h1 by 3. So bar 2 times 3 and 0.9294 times 3, I would have bar 6, okay, plus 2.7882. Then I could add bar 6 to 2, to the 2. So bar 6 plus 2 would give me bar 4. Okay? So it's important that you understand that if you're going to multiply, you need to separate. You need to separate. Then do the multiplication, then add the two values back together. Now for division, it involves separation as well, but it's a little more advanced than multiplication. Okay, let's see what we're talking about. So for division, you have, this is an example, you would also separate, yeah? You would also separate bar 1.5577, you separate that into bar 1 plus 0.5577, right? Now, but remember that it's not possible to divide 1 by 3. It's not possible to divide 1 by 3 without obtaining a decimal or a fraction. But you don't want to obtain a decimal because that ruins everything for us in this particular context. So we need to do some kind of manipulation to make sure that we can divide without getting any remainders, right? Okay, so you need to ask yourself this question, this very important question. I'm talking about for the bar number now, for the bar number. That's in this case, the bar number is bar 1. Okay, so you need to ask yourself this very question. What's the closest multiple of 3 to 1? Or it could be another example I'm just giving you using this particular one. What's the closest multiple of 3 to 1 that's very close to 1? Now the multiples of 3, 6, 9, okay? Now the one that is closest to 1 is 3. Yeah, the one that's closest to 1 is 3. So what do I need to add to 1 to make it 3? That's the question you should ask yourself. What's the closest multiple of 3 to 1? First of all, the multiples of 3 are 3, 6, 9, and the rest. So the closest there is 3. So what do I need to add to this bar 1 to make it something like bar 3? Right? Simple, you need to add bar 2. Right? You need to add bar 2. It's as easy as that. But I usually say this in mathematics and in any science field. In fact, in life in general, there must be balance. If you're going to do something, if you're going to add something to a particular system, you must find a way of also accounting for that addition, either by subtracting it from somewhere else. For example, you want to buy, you have a budget that you use for your household every year, and then you need to increase the money that you're going to use for probably feeding, maybe the prices of foodstuffs are going up, and you need to increase that money. But the yearly budget, the total income is not going up. For example, that's the worst case scenario. Now, if you're going to increase the money for feeding, for food in that household, you need to also reduce something, right? That's logical. If not, something else gets to suffer. So you're going to have to reduce. Okay, probably you've been spending a lot of money on entertainment. Okay, yeah, feeding is very important, so I'm going to increase the money that I'm spending on feeding, and I have to in turn reduce the money that I'm spending on entertainment. So if you're going to do this in mathematics now, we are applying this to this bar numbers. If I say I'm going to add bar 2 to the 1 to the bar 1 to make it bar 3, I must also add, okay, I must also do something else. Let's look. Let me not tell you the whole thing. So I must also do something else. So bar 1 plus 0.5577. So if I'm going to add bar 2, can you see that? If I'm going to add bar 2 to the bar 1, what did I do for the 0.5577? Can you see that I also added a 2? It's like a complement. The complement of bar 2 is 2 because negative 2 has its inverse as positive 2. So if I'm going to add bar 2 to the bar 1, please take note of this. I must in turn add 2 to the fractional part, to the 0.5577. If not, my work is not balanced. And I mustn't use a number that isn't going to give me a multiple of 3. It should be the closest multiple, and it should be a number that gets you to the closest multiple. So bar 2 is our option for this question. So bar 1 plus bar 2 now will give us bar 3, and the fractional part would become 2.5577. Now I can do this without having issues with my bar number, because bar 3 divided by 3 is bar 1. Do you get it now? So bar 3 divided by 3 is bar 1, and 2.5577 divided by 3 would give us 0.8526. And in turn, this would be our final answer, about 1.8526. Now, I want you to understand that if you had gone ahead to do the division by 3 without this method, you won't get the right answer. That would probably give you 0 point something, right? Try it out and see. It would be very, very confusing, and it won't result in the correct answer. So you need to understand this principle of separation, then addition of a value that makes it a multiple of whatever you're dividing it by, then balance before you can as well go ahead and divide. Okay, so it's very important that you understand these things. If you're a bit maybe confused or anything, you could take your time, pause it, try to internalize what you're hearing, try to write it down and see if you can actually translate everything you've heard on paper. Okay, so let's move on. So let's take an example. We are to evaluate this square root of 2.067 over 0.0348 times 0.538. Okay, remember we put our number and our log, and I said in the last class that I like to create a third column for my work to look a bit presentable, right? Good. So let's start with the numerator. The numerator 2.067, there's nothing else beside it, so we just use our log table. You can check yours. So this would give us 0. It's already in standard form, so 0. If you check 20 on the 6 difference 7, you should have 3154, so 0.3154. That's our numerator, so we can just cross that out. Let's talk about so we can take it to the third column. That's our numerator. Let's talk about the denominator now. So 0.0348 should give us bar 2. In standard form, this would be 3.48 times 10 raised to the power of minus 2. Okay, so bar 2, then you check 34 under 8, so bar 2.5416. Then we check 0.538. This would give us 5.38 times 10 raised to the power of minus 1, so bar 1. Then we check 53 under 8, so by 1.7308. Now multiplication, remember our principles, multiplication becomes addition here. Okay, so we add together and we should have this 6 plus 8, 14. Carry 1 here, 1 plus 1, 2, 4 plus 3, 7, 5 plus 7 would give us 12, 2 carry 1 here. Now 1 minus 2 minus 1, that's 1 minus 3. Remember that bar 2 and bar 1 can be treated as minus 2 and minus 1. So 1 minus 3 would give us bar 2 here. So this is our denominator now. We can take that to the third column. Now remember that between the numerator and the denominator we have a dash, which is actually division, right? Now that division would change to minus. Remember our law that division changes to minus. So we subtract this 2, okay? So 4 minus 4 and 5 minus 2, then we borrow 1 from here. That would be 11 minus 7, then 2 minus 2. Now, this is critical. The bar point here is critical. 0 minus 2. Some would just go further and write minus 2 here. That will be wrong. 0 minus 2 is 0 plus 2, okay, which gives us 2. I need you to understand that. Then the next thing is we have a square root sign here. So we need to change that square root sign based on our principles to division by 2. So we'll divide this by 2. If we divide properly, we should have 1.0215. 1.0215. Now, of course, this is not our final answer. Remember that we need to find the antilog. Okay? So if we find the antilog, we should get 10.51. Okay, remember that if you're going to find the antilog, you would check 0.2 under 1 difference 5. 0.2 under 1 difference 5. That would give us 1.051. Then remember that we have 1 as the integer here. So that would be times 10 raised to the power of 1. So I've taken the liberty to write the final answer as 10.51. Okay, so that's the example. Now the thing about this topic is it's not difficult, but you need to understand the principles. You need to understand the principles that guide the calculation. You need to understand the principles that also guide the finding of the log and antilog. Then you need to understand the principles that guide the addition, subtraction, multiplication, and division of these bar numbers. It's not the usual for the previous, like the one we discussed in the previous class. So if you can understand all these things, then you can solve any question, even if the question looks, I don't know, so long and terrifying. There's nothing you won't be able to solve if you can understand these principles. Like I always say, there's nothing difficult in mathematics. It can be challenging, it can be complex, it can be long, and it can take a lot of your time. But once you understand the principle, once you get the basic principle that guides whatever calculation, you're good to go. The main issue now is getting to that point where you're ready to stay on that calculation until you understand the principle. That's where the resilience comes in, okay? So you need to be resilient, okay? So let's talk about the relationship between indices and logarithms now. So, for example, if we say, remember when we talk about indices, you have, for example, a number raised to a particular power. So if you have a raised to the power of x, and we say that a raised to the power of x is n, now, if you want to translate that to logarithms, this is how you put it. You would say log n base a, okay, log n base a equals x. Now this is the, I think I told you in the last class to try to research on that relationship. Now this is the mathematical relationship between the index form and the log form. Okay, I need you to understand this concept. Okay, so a raised to the power of x equals n, then log n to base a equals x. So let's take an example. For example, you're asked to find x. In this case, you're asked to find x if log 64 to base x is equal to 2. What do? Now, some of us might be, should I say, you might have the foresight to do this, in a jiffy. But we could also apply the index form. We could change this to index form or to relate it as an index. So let's look at how do we apply this now. Remember that if we're comparing this to this, then it means what we're supposed to do here is, this is a raised to the power of x equals n. That means x raised to the power of 2 equals 64. Okay, so just compare this with this. So x raised to the power of 2 equals 64. That's what you're going to do. Okay, so x raised to the power of 2 equals 64. Now x would be square root of 64. You want to get rid of the square, you find square root. So x would be square root of 64, and that would give us 8. Now that simply means that log 64 to base 8 is 2. Now there's another way you could simplify this anyway, but that would be for something for another day. But I want you to do your best to not just watch the video and just talk about what is in the video alone. I want you to go outside, think outside the box, solve more questions, practice. That's how you become better. Okay, so we've talked about logarithms of numbers less than 1 today. We started with how to find the logarithms with the tables and how to find the antilog. Then we moved on to analyze bar numbers, okay, numbers that have bars. How do we add them? How do we subtract them? How do we multiply and divide them? Before we now went further and took an example of calculations that involve such numbers. Then lastly, we just looked at the relationship between indices and logarithms. So I think everything we've talked about today has been easy. But if you don't understand one or two things, you could go back and watch it again. And of course, you could put your comments. If you have something else that you want to understand fully, you could drop a comment and I'll do my best to get to it as quickly as I can. Okay, so let's talk about what you're going to do for me. Actually, it's for yourself anyway, but I'll be happy if you can actually practice these questions. Try. Let's see what you can do. Use logarithm. Use the logarithm table. Don't just use a calculator. Try to use a logarithm table. Arrange your work, and you can leave me a comment if you were able to get the answer. Let me also see your final answer. Okay. So it has been lovely talking to you guys again this Thursday. I hope you continue to have a lovely day. And remember, practice makes perfect. Right? Bye-bye. Don't forget to like, share, subscribe, comment, and tell your friends. Okay, bye.